Welcome to video 2 of the review of the PARCC geometry questions that was released in 2014. This is our review for the AIR test of 2016. AIR has purchased PARCC questions, plus they're going to be somewhat alike as we work them. In our first question here, we're dealing with the equation of a circle. We're going to want to answer some questions about it. In part A, we want the y coordinate of the circle. So what we're going to do is we're going to look at the y's. We have y squared plus 2y, and we want to complete the square for this. So what we do is we take the term that has just y, and we're going to take half of its coefficient. Half of its coefficient is 1. Now, take that 1 and square it. That gives us 1. So what we're going to do on the left side is we're going to add in 1. That means on the right side we also have to add 1. And this expression here is equivalent to y, and then the number we had was a positive 1 was the half, y plus 1 squared. So our y value is going to be negative 1. Now we aren't asked for the x value, but we do need it to find the radius in the next part, so we do a similar thing with the y. Take half of the negative 4, which gives us negative 2, square it. So negative 2 squared gives us 4. So we're going to write x squared minus 4x plus 4. And since we added 4 on the left side, we have to add 4 on the right side. And this, if we needed something about the x, this one would be x subtract 2 squared, because it was half of negative 4 is negative 2. Now on part B, they're telling us our radius is 7. The constant number, this number here, helps me with my radius. So in this case, my radius is associated with b plus 5. Now this number on this side is actually my radius squared. So b plus 5 has to equal 7 squared. So b plus 5 would be 49, and b would be 44. The next problem, number 7. In the coordinate plane, ABC has the vertices as shown. DEF has the vertices as shown there. Choose from the drop-down menu to complete the sentence. Okay. And the dilation under what particular factor? So we have to choose our point of dilation first. And then what are we multiplying the x's and the y's by? Well, if we choose 0, 0, that means we take any particular x, how far it is from 0, and any particular y, how far is it from 0. Well, if we choose 0, 0, this is 1 away from 0. To get to 4, I have to multiply by 4. So if I take my y, again, my x is 1, so to get to 4, I have to multiply by 4. But if I multiply by 4 here, that doesn't give me the negative 3. So my center cannot be 0, 0. Choose one of the other centers. If I choose 1, negative 2, or C, I would go through the same process. On the next question, number 8, this is calculator question, so the previous ones were all non-calculator. In this picture, it shows a triangle inscribed in a circle. We know angle CBD is 44 degrees. On these questions, you'll have scrap paper. Even though they're on computer, I would suggest make a rough copy as quick as you can of what this picture is. Now, CBD is a total of 44. So C to B to D, that angle is 44 in there. Now because this is a circle and point D is the center, these two are both radius, so they both are exactly the same thing. So that triangle CBD is isosceles, which means that this angle here is also 44. In doing arithmetic, let's see, 180 is the total triangle. Take away the 88 we already have. Makes this angle 92. Now we want angle BAC. BAC would be this angle here. It cuts out this arc, so if we know that arc, we can find the angle. Now since the central angle is 92, the arc is 92. And the angle down here, angle BAC, is equal to 1/2 of 92. Remember, if their vertex is on the circle, that's what we call inscribed, and it's half of the arc. So 1/2 of 92 turns out to be 46. Number 2, figure shows these lines R, N, and P intersecting at angles numbered 1, 2, 3, 4, 5, and 6. All three lines lie on the same plane. They're all on the same surface. Based on the figure, which of the statements would provide enough information to conclude that R is perpendicular to P? Well, we want R to be perpendicular to P. If they're going to be perpendicular, then they need to form 90-degree angles. So if I take the picture, that means that this has to be a 90-degree angle. This has to be a 90-degree angle. This has to be a 90-degree angle. And this has to be a 90-degree angle. So if I look over here, angle 2 is 90. No, angle 2 plus angle 1 has to be 90, so it's not letter A. Letter B, angle 6 is 90. Yeah, angle 6 is 90. That would be enough. So B would be a choice. Now notice it said which of the individual statements, which means there could be more than one. Angle 1 plus 6 is 90. Well, 6 is 90 and 1, now that's going to add up to be more than 90, so we throw that out. Angle 3 equaling angle 6. So that's a little tricky. Angle 3 and angle 6 are vertical angles. And vertical angles are always going to be equal, no matter whether they're 90 or not. So knowing that they're equal doesn't make it necessarily 90. 3 plus 4 adding up to 90? No. Because angle 3 is going to be a 90 because we have R and P. So these two lines, that would have to be 90. This would have to be 90, so 4 plus 5 also has to be 90. So B and F would be our choices here. And our next one, we'll finish off with this particular page on this slide, so questions 3 and 4. In the right triangle, the measure of angle B and angle C are not the same. Let the sine of B be equal to R, and the cosine of B be equal to S. What is the sine of C? Take away the cosine of C. Is it R plus S, R minus S, S minus R, or R over S? So let's name the parts of this triangle here. Here's angle A, so I'm going to call this little a out here. Here's angle B up here, so I'm going to call this opposite it little b. And here's angle C, so little c over here. So in terms of this picture, the sine of angle B, well, sine is the opposite, which is B, over the hypotenuse, which is A. So the sine of B is equal to little b over little a, which they told us was R. And the cosine of B, see, cosine of B is the adjacent, which would be C, over the hypotenuse. So C over A is the same thing as S. Now they want sine C minus cosine C. So sine C, The sine of C, this time C is my angle of reference, so here's C. The opposite would be little c over the hypotenuse, which would be A. So the sine of C is C over A. But over here, we already know that C over A is equal to S. So the sine of C is going to be S minus the cosine of C. The cosine of C is adjacent, which is B, over the hypotenuse, which is A. B over A is the R value. So the cosine of C is R. So the expression would be S minus R, letter C. Remember, at any time you can scroll back and unerase what I have there. Triangle ABC is shown in the coordinate plane. It's going to be rotated 180 degrees clockwise around the point 3, 4 to create triangle ABC, A prime, B prime, C prime, indicated whether each of the features of the image will or will not be the same as a corresponding feature in the original triangle by selecting the appropriate box. So here, what we're doing, all right, the coordinates of A prime. Well, when we rotate something, the coordinates change. So this one will be not the same. The coordinates of C prime. See, C prime. If I rotate it around 3, 4. Well, 3, 4 is C prime, C. So if I rotate around that point, C prime is going to stay C prime. Won't always be the case that we'll have this. The perimeter, the distance around the triangle. Well, if I'm just turning a figure, imagine turning your desk. Does it affect any of the measurements of your desk? No, just the orientation. So the perimeter is going to stay the same. The area is also going to stay the same. The measure of angle B. Again, think about your desk. If you were to rotate it, do the angles on your desk change? No. So the measure of angle B is going to stay the same as well. And finally, the slope of AC. Let's see, here's AC. It has a slope. Okay, so its slope goes up to the right at a particular rate. It looks like it goes up 2 for every 8 it goes across. Now we're rotating 180 degrees around point 3, 4. So again, 3, 4 is this particular point, and we're going to rotate it 180 degrees. So C stays where it is. Rotate 180 degrees. It's going to come out like that, and A prime is going to be out there somewhere. So in this case, on that 180 degree rotation, since one of the endpoints was right on the rotating, we're not going to be changing the slope on this case. However, some of the other lines do change the slope. Notice this line here. If we rotate it 180 degrees, it's going to be something like this. And it does have a different slope. Well, that's the end of this first one, or the second one actually. We'll get back to the third one shortly.